All right, in this video I'm going to go over some basics of vectors and then how to write component form and magnitude for a single vector. So first things first, what is a vector? A vector is a directed line segment. Here's the notation here. It kind of looks like a ray symbol. It's going to have an initial point at P and a terminal point at Q. And since it's really technically a line segment going in a specific direction, it does have a length. So we're going to go ahead and draw this vector. We want to plot point P at -2, 5. So I'm going to go left 2, up 3, 4, 5, and that's point P. So that's where our vector is going to start, and our vector is going to end at Q. We'll plot point Q, right 4, down 1, and to draw this vector, we're just going to make it look more like a ray. It's going to have an arrow next to the terminal point. So again, it begins at it begins at P, it ends at Q. And then another way to note a vector is with a bold lowercase letter. So we can also call this vector V, and when they note that on a graph, they're just going to put a V there right next to the graph. So now we're going to find component form, and there's some notes on component form above. We want to write this with pointy brackets, okay, and the first value of our component form is going to be the horizontal component. That's basically how far the vector moves when we travel from P to Q horizontally, or what distance I travel on the graph when that happens. And then the vertical component is how I move up and down from point P to point Q, and that's going to go in the second part of our vector coordinate, which again we call component form. So there's two ways to do this. One way is with, it's almost like a slope formula here. So we can go vector V equals, all right, we'll make this pointy bracket here, and we take the second x value and subtract the first x value. Again, this is like the run part of the slope. So my second x value is +4, and then I'm going to subtract my first x value, which is -2. And we'll start simplifying this down here. 4 minus -2 is 6. So my horizontal component is 6. Okay, for the vertical component, we're going to take the second y value, which is -1, and we're going to subtract the first y value. And we add these up. -1 minus 5 is -6. So my vertical component is going to be -6. And I could check these on the graph, and we can actually find these on the graph if we wanted. Let's see how far horizontally we travel from P to Q. That's going to be in this direction here. We went to the right, 1, 2, 3, 4, 5, 6. Okay, so that checks out. And then let's see how far we travel vertically from P to Q. So I would go in this distance down 1, 2, 3, 4, 5, 6. -6. All right, another way to define component form is if I were to trace vector PQ and slide it so the initial point starts at 0, 0, it would land at my component form coordinate. Okay, so I would travel right 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. And it's at 6, -6. So if you put the vector at 0, 0, it will always land at your component form. Okay, so definition of a vector, it has two things. It has direction and it has magnitude, as stated by the character vector from Despicable Me, one of my favorite cartoon characters ever. So we're just going to use this as direction for now. There will be a better way to find direction with trigonometry coming in the next section. And then for magnitude, that's the length of the vector. So we can use this little formula here, which is derived from distance formula. All right, magnitude is noted with absolute value bars. So we're going to say magnitude of vector v equals, and then we're going to take square root, and we already found our component, so it's square root of the horizontal component squared plus the vertical component squared. Okay, 6 squared is 36. Negative 6 squared is also 36. And then we get square root of 72. And if we made a factor tree to simplify this, it would break down to 36 times 2. 36 is 6 times 6. So we're going to have a pair of 6's and then a 2 left over. So our magnitude is 6 times the square root of 2 here. You can see that value from Pythagorean theorem as well. Because remember, if we made a triangle out of this with horizontal and vertical components, we have 6 for this side, we have 6 for the vertical side. 6 squared plus 6 squared equals c squared. If you solve that for c, you'll get the same answer here. Okay, so that concludes the first part of this video.